But there are some beautiful experiments, particularly, actually, there's a really lovely one with alcohol, if I can digress into alcohol for a minute again, which is there's a particular type of mouse called the agouti viable yellow mouse. And some mice in a litter with this will be skinny and brown, and some will be fat and golden, and they're very, very cute. And they're all genetically the same. The difference between their phenotype is just due to their epigenetics. It's a particular region of their genome which has different epigenetics. Work from a great scientist in Australia called Emma Whitelaw shows that if you give a female mouse alcohol and then she has babies, that the ratio of skinny brown babies to fat yellow babies changes. And so that's showing you that alcohol intake in the mother is affecting the epigenetics of the next generation, because the link between the appearance of these mice and their epigenetics is pretty much one-to-one. So it's a beautiful example of where you can show that an environmental stimulus has a major epigenetic effect, if that makes sense. And is any help?
Sure. It opens up a whole bunch of different questions, like along the lines of, even if we talk about the obesity epidemic, and I don't, and correct me if I'm wrong, but I don't think we fully even understand the impact of what the mother does, ingests, the impact on the baby. So let's say for, for the purpose of this discussion, let's say what the mother is completely eating or desiring gets translated on the child. And at that point, maybe if she's eating maybe a lot of fast food or a lot of, a lot of these things, that maybe that could make a child predisposed to having a palate that, maybe hits the reward center of the brain for salt, fat, and sugar more than someone that is eating a lot of vegetables and all of these things. Like, is that a reasonable thing to say?
It's a reasonable hypothesis. It's a hypothesis that you can test to some degree in rodents. You can test taste preferences. And we do know that if, for example, a mother is very obese during pregnancy, that has long-term consequences for her offspring, for her children. And epigenetics is giving us very interesting ways of exploring that and understanding, again, why these very early experiences, even in utero, can affect you for the rest of your life. I think the thing, though, that we need to remember is I absolutely adore science. I'm wearing a jumper that says geek, for heaven's sake.
Oh, I love that. I couldn't see the full word.
Yeah,
That's
there
great.
You go, geek.
That's great.
Yeah, I love science, but I think we also have to be very, very careful not to think we can science our way into and out of every problem.
Right.
So poor maternal nutrition has a very major effect on offspring and their health. In some ways, you could argue, do we really care why? We know that it has this effect, and we know it's almost always due to poverty. The biggest thing that is going to affect a child in their life is if they come from a poor family. We don't need to understand the epigenetics to start addressing that.
Right.
We don't need to know every single metabolic step that leads to those poor outcomes. You could argue it would be much, much cheaper just to tackle poverty. So it's, to me, I'm in this sort of double-edged position where I think it's scientifically very interesting and sociologically almost irrelevant.